Hi everyone, welcome to this webinar, SolidCAM Simultaneous 5-axis Part 4. We will start in approximately 2 to 3 minutes from now. We'll wait for some more people to join in. Thank you very much for your patience. Uh, sorry. Okay. So you should be able to see my screen. Let's start. So we have this part here, and this is a pretty simple part. But what is more important here is if I measure the height of this part, this is approximately about 194 millimeters. So it's pretty deep. And I'm interested in machining this surface. Okay. So I would like to machine this surface. Definitely, if I use a flattened mill, I'm not going to go more than the end mill itself, and plus it has a curvature, so you cannot expect an end mill to machine this curvature. The other option that is left out is for me to use as a ball nose tools. Of course, ball nose tools will work on this part pretty well, but the whole idea of ball nose tools on this part is going to be a bit more preposterous, I would say, because no matter what size of ball nose tool you use, 16, 20, 25, you're going to end up with a very fine side step to generate a very fine scallop on this surface. So the circle end mills basically offer a solution here. Now, what are circle end mills? And circle end mills are basically of the known forms are three forms. One is, so one is what we call as a classic barrel, where you have that shape and the shank, of course, where this radius here, it's pretty large. We are talking of anywhere between R80 to R100. Okay, and you may or may not have a radius here, but we can use this large radius to generate the same scallop. For example, if I draw here two circles of large radius, and if I draw another one, this is my step over. Basically, this is my step over. Now, this step over, let's say, is 2 millimeters, and I get a scallop height here of, let's say, 0.01. To get the same scallop of 0.01, and assume that this was R90, to get the same scallop of 0.01, if I go with a smaller diameter of tool, let's say 16, okay, I will really have to cut down on my step over. So this step over here could be as small as 0.3 to 0.5. So we are talking about, to get the same scallop of 0.01, I have to go down to a side step of 0.3 to 0.5, whereas with this kind of tools, I can really ramp up my side step to get the same scallop. So we basically are going to use the large radius of the circle end mills to get a very fine scallop that is needed to machine these surfaces. So if I go back into SolidCAM, if I go back to SolidCAM, if I go into the tools, so first is basically the support itself. So if I go into my tools, you can see that we support barrel shape, the classic barrel. We also support oval form tool. We support the lens form. Basically, this has got the large radius at the bottom of the tool, and we also support the taper form. So currently, we are supporting 4 shapes of the circle end mills. Soon, we will start to support another complex shape in the circle end mill table, which is called as a double barrel, where it has got the form of a lens at the bottom and a form of the oval on the side. So it will have both the shapes in a single tool. This will, of course, be somewhere down the line this year. So we support, first of all the given tools that are currently available in the market. Okay, and the definition also, I will show you how we define the tools. So I would like to machine this surface here with an oval form tool, and the parameters basically are to achieve a scallop of, let's say, about 4 to 5 microns. I need to take, or 2 microns, I need to take a step down of about 1 millimeter. And if I have to do the same thing using a ball nose, then my step down comes to 0.2 to 0.25 with a 16 diameter ball nose. So we are going about 3 times more step over than a ball nose tool straight away with the oval form end mill. Like before, to avoid, to reduce the time of definition, I have got my templates. So I will apply my template from here, and let's go to the oval form. Basic, yep, that's it. So I'll apply that. All right, so I've got my toolpath here. And what do we have here? First of all, I'm going to use morph between 2 curves. So let's define the geometry. Drive surface, I already have this in my library of surfaces that I've defined. So this is my drive surface that I'm going to use. The start edge curve is simple straight edge curve on the top, and the bottom edge curve is that one. Okay, the tool I'm using here is a oval form tool. I've taken this from the catalog of Imug, and this is a 16 corner radius, small corner radius 3, and the large radius, the profile radius of 75. So we are going to use the 75 millimeter radius to our advantage of getting a bigger step over, yet generate a smaller scallop. Now, the total length of the tool is 92 millimeters, out of which I have kept 60 millimeters out of my holder. So we are going to be restricted by the length. However, the beauty of these tools is that, and the beauty of the software is that you can control a lot of things and use really short tools to go deep into the part, which is almost 194 millimeter deep. And I also have used a holder suitable for 16 diameter, 16 end mill. That's about 120 millimeter. That's the holder length. And if you look at the shape, so if I go into the cylinder, basically, we're talking of diameter of 27 millimeters here. So that's the holder I'm using. Okay, levels. Okay, we're not going to touch here anything. Step down is going to be approximately 1 millimeter. Now, depending on the material, depending on the profile radius, the large radius, this could be anywhere between 1 to 1.5 millimeter. Okay, so I'm going a little bit conservative. I'm going with a 1 millimeter step down. It's going to be zigzag. And the best part is coming here in the tool axis control. SolidCAM allows, the moment you define a barrel tool, it allows you to define the side tilt using the contact point of the tool. Okay, not any angle, nothing, just simply contact point. Now, the contact point definition will depend on a couple of things. Okay, first one, it will depend by the height. Now, what do I mean height? Okay, so let's make a new sheet and I'll explain to you. Okay, so if this was my large radius, small radius, and large radius again, that's the tool. Now I can define what should be my contact point. This is taken as contact point 0. This is taken as contact point 100%. Okay, so I can tell to SolidCAM that I would like to take a contact point at 30%. So it knows that this is going to be the contact point and it will tilt the tool accordingly based on this contact point. Okay, so that's number one. Number two is by line parameter. When you say line parameter, that means it is expecting, or it's going to take this entire section of the barrel. And then it will ask you a couple of things for the contact point. Which profile do you want to consider? Barrel profile or full profile? That means, do you want it to consider 0 here, or do you want to consider 0 here? Okay, you can be very specific. The small radius or the large start of the large radius, you want your 0% to start from. In most of the cases, I prefer to start the 0 from the barrel start or the barrel profile start, and this is my 100%. So I can say again 30%, but now the 30% won't be here, but the 30% will be somewhere here. Okay, so it knows that this is going to be the contact point and it will tilt accordingly. But you've got another method of handling. For example, if you really have deep surfaces like this, okay, if you say my contact point is 30, so what will happen is the tool will come here at this point here and it will stop. So my cutting will actually stop here. We have got another way of handling such deep parts wherein we give a range. So we can tell to SolidCAM, don't start at 30, but start at 80% and go all the way to 10%. So when it starts the first cut, the tool will be aligned this way. And when it ends, the tool will be aligned this way. So the first contact point is going to be here. The last contact point is going to be here. Okay. Thereby, you can use the complete profile as much as possible to cut the surface. And this is what we are going to do here. So I'm going to say start at 60% and to value is stop at 20%. So I'm going to use this particular method. So the first contact point is at 60%. The last contact point is going to be at 20%. However, when you say the last contact point is going to be at 20%, in that case, the tool is actually going to go much below the surface here. So it is actually going to collide against the surface. So the moment we say stop at the surface, then probably it will have to violate this 20% figure that I've given it. It may not stop at 20%, but it will stop much earlier. It could be at 28 or 30%. It will just stop because I'm asking it not to collide below. Okay. Else it will have to tilt so much that is again going to violate my other surfaces. Okay, so my preference is it should start at 60% and it should go all the way down to 20% or as much as possible. Side tilt is nothing new. We are going to use the same one. It's ortho to cut direction at each position. Okay, and in the gout check, however, I would like to do some collision check, especially with the holder, arbor, and the tool shaft. And the check surface here are all these surfaces: the fillets, the side surface, the bottom fillet, this side, everything. I want the tool and the holder to take care of this geometry. And I would like to keep 2 millimeters material. I want it to stop 2 millimeters before itself. We can use our regular machining features, 5-axis machining features, to remove or to machine the area that still will remain after we have attempted with the barrel tool. Okay, perfect. Let's save it. Right, and let's calculate this toolpath. Perfect. So we have a pretty nice toolpath. You can see something else happening here. That is because of the holder that's coming in contact. The tool is not long, so the entire holder gets in part. So let's look now at our. That's very important. Let's like to take a section here. Okay, let's switch on the simulation. Contact. My first contact is, that's the point that it is making. At the contact, it reaches the end. It's slightly, so it's much more each of the tool. It's not down. Contact point from to come as close to top because of this 20%. It will be clearer than what is. And almost down to here. We'll have some more little. Yeah, that's it. Point. You can see that it, with respect to the, yes, my emphasis. So we go a step for tools, which are basically the circle end mills. You can vary your contact point. Thereby, number one, you can go very deep into parts. Number two, your tool wear uniform through the tool. It be doing at point. You can keep changing point as okay. So it's pretty when it comes to handling circle end mills. Right. So this easier tool, I would say. Sorry, rather part. A bit more into the let's open that more or less like a part that would go on this application for all the barrel tools. So I would like to machine the blisk. Basically, I would like to machine the blades surfaces. Now you can see that the area between them is very tight. Okay, so it's be a great challenge for end mills to perform in this. Obviously, the tool is not going to be pretty long, so it cannot machine the entire area. It will have to stop at some point. Okay, so again, here I have got my template, so I'll apply a template, and in this case, an old form blisk. Apply that. Again, I'm going to use morph between two boundary curves. In the geometry, my drive surface is that. Okay, those are my drive surfaces. And start edge curve is that. and the end edge curve here is, of course, the second one. Okay. Couch check in this case, I would like to use only the top surfaces because I want to stop them when it comes close to these surface here. That's one. Okay, so, and the tool here I'm using is again a oval form tool. This time it's diameter 10, small corner radius is 2, the profile radius is 85. Approximately 1 millimeter is going to be my step down here. And outside holder, as you can see, is 90. But if you look at the height of the blisk, it's more than 80, 85 millimeters. So it's obvious that it cannot go completely down. At the most, it'll go up to 50 millimeters or 55 millimeters, depending on the couch check. And let's say OK. Toolpath parameters. You can see my step over is approximately 1 millimeter. Link. I'm using an automatic lead in and lead out. Okay, so let's save it and calculate this blisk. Take approximately 20-25 seconds to calculate. Okay, you can see what has happened. But here, I've used a different method of contact. I cannot go by the from and to method because, as I said, there is no much space for the tool to tilt too much inside between the two blades. So I have used a constant contact point at 40% of the tool or the barrel form. So at 40%, which is basically going to be somewhere here, okay, it's going to be approximately in this area here. So that's where my contact is. I have not used the from to method, just at 40%. If I look at the simulation, this is how my simulation is going to look like. So I'll stop it here. So you can look at the contact. That's where I'm taking my contact exactly. Okay, so that's approximately 40% of the barrel profile. And as it goes down, you can see that it doesn't completely machine it. It's trying to keep the contact point at 40% point as much as it can. Okay, but it definitely be always on the large profile radius. Now, because of the tool limitation and the holder, you can see that the machining stopped right here. Okay. Now, what happens below this? Of course, you cannot use a barrel tool because unless and until you really have got a longer barrel tool, you cannot go below that. Otherwise, you will violate the surfaces on the side. So whatever now remains needs to be done with your regular ball nose tool or taper ball nose tool. So this is exactly what I'm going to do. I'm going to add another operation from the template. And this time it's going to be a taper ball nose. Okay. And it's again morph between two curves, and we will use the same geometry here. So it's faces, contour, contour 1, and the tool here is a 16 diameter corner tip radius 3 with a 4-degree taper. Okay, tool axis control, I'm tilting it by 80 degrees. Okay, and in the couch check, however, I am going to use tilting tool. I do not want the tool to collide with these surfaces on the side. Okay, I do not want to touch them, and of course, I also do not want the tool to get into this area. So I need to give even these surfaces as my collision surfaces. Perfect. Let's save this and calculate this toolpath. Of course, I've given the range. The range has to be slightly overlapping into the first tool path and go down completely till the end of the blade. Okay, so again, it's going to take about like 22 seconds. Done. And that's my toolpath using the taper ball nose. You can see that I have got a much bigger step down here than the barrel tool, right? Now, apart from this, there were questions on how do you rough out such parts using a generic 5-axis. Now, these parts can also be done using the multi-blade functionality of SolidCAM. It's like almost automatic. But in event you do not have multi-blade functionality and you would like to do such parts, you can still do it without generic functionality. Okay, so I'm going to also show you the roughing of the blades using the generic functionality. So let's again go to my templates. I'll add an operation from the template and just have a search for oops. Okay, that's the blisk roughing. Let's apply. Okay, so what I've done here is I'm using a functionality called parallel to surface. And in the geometry, I have to define a set of 2 blades. So it's perhaps I'll just look at the surfaces that were selected, not that one. So what I've done here is I've defined a set of 2 blades, and the cuts are going to be parallel to the edge surface, that one. So it's going to be parallel to that surface. Perfect. Let's switch off this one. And what I have here in the tool axis control is 90 degrees. I'm using again a taper ball nose tool here for my machining. And gouge check must be applied. And here I'm applying gouge check for the arbor, tool shaft, and the tool tip. And I'm using the tilt tool automatic. So let's calculate. What we need to get is one single pass. Sorry. We'll just say I would like to have one single cut. 1. Okay. Let's calculate this tool path. It's imperative that you get this tool path right to get your roughing right. For you to get the roughing right, you need to get the first slice right. After that, it's much more easier to apply the roughing. So we have got a pretty nice tool path here, single strand, continuous tool path around the 2 blades. After that, it's simple. I simply go into the roughing and more and go into area roughing. I switch on area roughing. My rotary axis in this case is the 4th axis is rotating around Z. Okay, so the rotation is happening around Z. So I need to specify the rotation axis here. Specify what is going to be your step over. What kind of machining do you want? Zigzag or one way? What kind of machining? And the calculation must be applied after the collision check has been performed for the blades. Okay, so let's select OK and hit the calculate button. Okay, calculation is done. Let's look at the result. You can see that I get a pretty nice result between the 2 blades. Okay, Now I only need to go into the geometry back again, and instead of one cut, I'll say 10 cuts or 20 cuts. Based on the depth of cut, you should get very nice roughing toolpath. So actually, even if you don't have multi-blade and you would like to machine this blisk, you can do it completely without using multi-blade functionality. You can simply use the generic 5-axis functionality to machine this particular part very easily. Okay, that's how you can get roughing. You can even increase the depth of cuts. Instead of 10, you can say 20, 25. Okay, using this method, you can actually rough out the blisk. So what we saw today in the circle end mills was we saw a very easy, simple part. I used the oval form tool and I could machine the side surfaces, taking care of the surfaces on the side for collisions. We also saw how we could apply the contact point. We can make either a single point as a contact point, or I could vary the contact point on the surface based on the barrel profile, from starting from a certain percentage of the profile, ending at a certain percentage of the profile. We also got into the blisk. We applied the similar principle of oval form tools on the blisk. We also saw that area that cannot be done completely with the oval form tool because length limitation. We can finish it using the taper ball nose, using a regular generic 5-axis functions. We also saw the roughing of the blisk using our generic 5-axis function. Great. If there are more parts that you would like to see, we have one more series of webinar remaining next week. I can show you in that. Now let's move ahead to our another category of parts that would like to machine using multi-axis roughing. So let's open such part. I think many of you get such parts where you would like to machine the pockets and other things, and this needs to be done in 5-axis. So here again, we have got a part which needs to be done, and these pockets needs to be done in 5-axis, because if you try to do it in 3+2, it's going to be one hell of a job creating coordinate systems everywhere and stuff like that. So you would like to attempt to do it without defining all those things. And that's precisely what multi-axis roughing is all about. Okay, so let's look at pocket here, and we would like to rough this pocket out using multi-axis roughing. So let's again go to my templates, and I'll add a template here in multi-axis roughing. And here, the style that I'm going to use is what we call as a contour style, or regular HSR or turbo HSR roughing style. Okay, we use that style to do the roughing. So in the geometry, you can see that I have got two styles, the offset style and adaptive style. Okay, I'm going to show you both. What are the difference between an offset style and what is the difference between an adaptive style? So I'm here in this case going to use an offset style machining. We can go from offset from floor, offset from ceiling, or morph between the ceiling and the floor. In this case, I'm going to go offset from the floor. Okay, my floor surfaces, simple. I have got a color, so I'm going to pick the surface. You can see the RGB values are captured by SolidCAM, and I simply have to click on Find Faces, and it finds all the faces for me. So these are my faces, but this is not the floor. Floor in this case is going to be only one, that's the bottom. Okay, sorry. Wall, again, I'm going to pick from the model. You can see that RGB values are set here again, and I'll say Find Faces. So that's my wall, which also includes, by the way, the floor. SolidCAM is smart enough to understand what is going to be the wall and what is going to be the floor based on the geometry definitions that I've done. It sees that there is a duplication of floor surface here, so it will automatically remove that floor surface from the faces, from the wall surfaces. Okay. The tool I'm going to use here is a 50 corner radius for bullnose inserted cutter. Okay, levels you can see is automatic. The only thing we need to put in is the entry and exit safety distance. Constraint boundary, I'm not going to use constraint boundary. In the toolpath parameters, tolerance is 0.1. My depth of cut is 2 millimeters. My side step is 20 millimeters. It's going to be a one-way machining with regions. I'm smoothing the corners and the final contour so that there are no sharp motions. Stock in this case is going to be a local stock. It's not going to be a full stock. Okay, very important that we define only the stock for the region that we are machining. So in this case, I'm going to take a stock again, pick from the model. I'm going to again pick these faces here. Plus, I have created another surface which closes the area on the top, and that's here in my surface bodies. Fill number 1. So you can see there are 25 plus 1, 26 surface, which is the top surface here. Okay, that's done. Link, it's auto. When it is approaching, it needs to use ramping. And internally, whenever it retracts to the feed distance, it still must use ramping. And that's it. So we'll just save the operation and hit the calculate button. Again, it's going to take about 35 to 40 seconds to calculate. So you bear with me. Okay, this was pretty quick. It was done in about 10 seconds, and you can see the toolpath. And if I now run the simulation on the machine, okay, let's go to machine simulation. Okay, so that's the tool and the holder, and that's how my motions are going to be. That's a ramping. Ramping again here. That's how it will start machining it. Okay, next step, and so on. So you can actually take any part which has similar looking geometry or even completely different looking geometry, and you would like to rough that part in 5-axis. All it needs is a good definition of the floor and the walls. Once you have these two definitions, it can do the roughing in full 5-axis. Okay, you can see over here all my axis is moving, so it's totally completely 5-axis roughing. Right. So this style, we call it as the contour style or the HSR style or the offset style basically. And that's how my roughing is. Now let's look at another style of multi-axis roughing, and this is very similar to iMachining, the kind of toolpath that you get with iMachining. So it's going to be very similar to that. And if someone asks me, do you really have iMachining in 5-axis? Of course we do. We use these. We use a multi-axis roughing definition, and we use the adaptive functionality inside, and we can get a very nice looking 5-axis iMachining toolpath. So let's add again from my template. I'm going to use multi-axis roughing iMachining style. Since the material here I'm going to use is aluminum, so it's going to be a bidirectional machining. So floor surface again is that, and wall surfaces, say new. The color I will pick from the model. Click on find faces. Okay, so it's picked about 21 faces. Apply. The tool in this case, because I'm going to use an iMachining style, so it's a bullnose tool, solid carbon end mill, 16 corner radius 2. Most of the things here are not needed now because I'm going to say zigzag machining, I get an option here called as maximum step over and the desired step over. So it will vary the step over between 6 and 4.8. Now, when you can also define that when it's doing climb milling, it should take 100% of the step over. But when it's doing conventional, the up milling, you can bring it down to 80% of the step over. It need not be 100%. And when it is clearing itself from the bottom clearance, when it is clear, the tool is clearing from the floor surface, it should lift 0.5 millimeters from the full floor surface and then travel. Okay, I want only one slice, the final depth, because I'm going to use the full flute length for machining. Sorting, like I said, I'm going to use zigzag. My direction, main direction is going to be climb, but since it is, we are going to use zigzag, the second one obviously is going to be the conventional cutting. Smoothing is no longer available with the adaptive. Stock, okay, here again we need to define our local stock. So I'll pick from this, find, and I have another surface here which I've used to close this. This is surface fill number 2, so I should see 22 surfaces here. Okay, so that's it. So it's selected. Okay, link, automatic ramping. Wherever necessary, it's using the ramping properly. So let's save it and calculate this toolpath. Perfect. See an amazing toolpath here. The style is like iMachining. Okay, so let's run the simulation on the machine and see how the machine looks like. By the way, we have cut some parts using this functionality and really looks amazing on a 5-axis machine. Okay, especially when you're engaging the full flute of the tool, it's very, very amazing to look at the material removal that happens. Okay, so this is again the part tool. Let's run the simulation. That's the ramping. And that's how it's going to machine with the iMachining style, what we call as, in this case, it's a variable step over. You can also use the strategy if you would like to finish the floor of this model. You can use the strategy to finish the floor. Use a ball nose with a fine step over, and you could finish the floor of this particular part. And then you could just use the swarfing operation to do the walls. Okay, so now it goes into the zigzag mode, and that's how it's going to run the zigzag mode on the part in the pocket. Okay, perfect. So this is about multi-axis roughing. You can use this functionality to either rough out or even finish the flows of pockets like this. You can apply the same template and you can keep applying it to different areas of this part, and you can machine this. As usual, all these files will be available on the web of SolidCAM. For people who have already registered, this will be available along with the recorded webinar. Right, let's move ahead to our last component today of SolidCAM 5-axis part 4, and let's open a nice part because we are going to do another part of SolidCAM 5-axis, which is the tube milling or port milling. Right, so we have a part here, and we would like to machine this part. For example, if I take a section, this is how the inside looks like. Okay, this is how the inside looks like. and I would like to not only do the finishing, I would also like to do the roughing. Okay. Now, since this calculation takes about 1.5 minutes, I don't want to make you wait. So what we are going to do is I'll show you the definitions and directly the toolpath. So we have got port machining here, and under port machining, you have got roughing, rest roughing, spiral finishing, and plunge finishing. Why plunge finishing? Plunge finishing is needed by certain port manufacturers where they want the tool lines or the scallops to be generated in the direction of the flow of the gas. Okay, so that's the reason why we have given the plunge finishing option. Also roughing, and all we need to define is the surfaces here. Sorry, I'll click on show, and those are the surfaces that were defined. Everything, all the surfaces are picked up. The tool, we currently support both lollipop and ball nose tools for roughing. There have been demands, or there have been requests from several quarters to support bull nose and flattened mill. And trust me, using a bull nose or a flattened mill is not going to be easy in this method, but we are trying our best to support bull nose tools. Flattened mill, I don't think we'll support. Bull nose tools for sure we will support in the near future. And I'll show you why it is so difficult to support this, because the different contact points a bull nose tool generates when it's actually machining the profile inside. Levels, you can see everything is automatic. It's just like multi-blade. Everything is automated. You only need to define the path surface, the depth of cut, side step. But there is something slightly different here. We have got maximum step over and the step down. And in the sorting, we have got the output type. Now, in this case, we have got two areas. This is called as the top area, and this is called as the bottom area. Okay, so you can ask SolidCAM to machine only from the top side, however, how much is possible, or you could ask SolidCAM to machine from the bottom side, whatever is possible, or you could say machine from both sides, but you machine maximum from top, as much as possible go from top, or maximum from bottom, or go to the midpoint, or you can say user defined. So you can drag the slider and say go 70% from top and go only 30% from the bottom. Okay. In this case, we have used maximum from top, and I've also used the function called as roll over the edge, which means the first cut will be exactly on the edge, and it rolls over the edge to enter the material below. Tool axis control, you can see there's nothing. It just says output type and minimize tilting. No more functionality is needed. Link is also automatic. There's nothing in this. Gauge check, we have said check against the machining surface. Okay, and that's it. So if I now show you the toolpath, let's switch on the toolpath. And let's go here and say okay. You can look at the toolpath. Okay, let me change the color. Change this to blue. This is how the toolpath looks like. Between two areas, you can see it's ramped everywhere, and it machines taking into account even this. And once this side is over, it retracts itself, comes out, and starts machining from this side. So let's run the simulation and go into Solid Verify. That's the block. Let's run the simulation here. Okay, I'm going to stop it, and I'm going to go into the options, and here, let's go back again to simulate, Solid Verify. I'll set the region of interest, and my region of interest is y plus 54 to y0. So I would like to look only at the half of this particular part. Say OK. So you can now see I'm looking only at a section of the area, and that's how my roughing will happen. I just want to show this because I would like to show you from both the sides how it works. Okay, that's from top, so it's trying to machine maximum. It finished that, and now it's going to go from the other side. It's roughing it out, and that's it. You can see that it nicely machined it from both the sides, roughed out, and now it's ready for finishing. So you can now apply the finishing, and the finishing is also similar. We have got spiral finishing. I'm using the same tool. All that changes here is, again, just the step down. Okay, there's no more step over in this case. And in the sorting, again, you've got both maximum from top. So we are going to machine from both the sides with rollover on the edge. And how my toolpath looks like? My toolpath looks like this. And this is what I mean by rollover. You can see this rolling over of the toolpaths on the edge. Okay, you can see also that we are overlapping very nicely inside, basically to compensate for the tool geometry, so that we don't leave any areas that is unfinished. Okay, so this is a completely automated function for machining of tubes and ports. Now this was a pretty simple part. Now let's go into a real world example. So I will open a real world example. Okay, let's open directly here. Barrel, but in this case, port machining. Okay, let's open the part. Okay, what do I have here? You directly can see it, but this is the part. Okay, so you have got a real world example here where you have to machine these ports, these tube kind of geometries. There are two tubes here and they merge in and become one. Okay, how do we handle such geometries? First of all, I isolated the surface. So I've taken out the surfaces. So I have got the two tube geometries here merging into one. And what I only did was I applied a surface in between so that it segregates and makes it two single tubes rather than one tube with two nozzles. So I have got two single tubes, then it becomes very easy. Go into my first roughing, just calculate that's an eye machining toolpath. Okay, let's change the feed rate here basically because I changed the machine. Let's go to data. Okay, let's forget this for a moment. Let's suppress this operation. Let's edit the port roughing operation. And if I go into the geometry, the strategy again is offset. Again, here you've got two strategies, offset strategy and what we call as an adaptive strategy, which uses a similar like eye machining. You can use an eye machining kind of a style to do the roughing. And I have got the port geometry here. This is the port geometry that I've used. So this becomes one tube. This surface that I've used for segregation is precisely meant for defining it as one tube. And then I have got my tool here. You can see that it's a nice lollipop cutter. Levels is automatic. Toolpath parameters. Step over is 5. Depth of cut is 1 millimeter. Everything else, like I said, is automated. So I just save it. And let's go into that and calculate this toolpath. Okay, perfect. So our first roughing is done. You can see it was pretty quick. Okay. And similarly, I calculate for the other tube here. the method that I've used for both the tubes are different. Therefore, the different calculation times. You can see that I have not used any spine here, whereas for the second one, I believe I've used the spine. You can see that I've used the user-defined spine. Spine basically is nothing but a geometry that runs through the center of the faces that I've selected. It makes the job easier for SolidCAM to do the slicing. Okay, but obviously the automatic spine works much faster. Obviously, let's also calculate the front one. Simple. This is a much simple geometry. So what I have here, if I go into the let's change the color again, otherwise the visibility is not good. Number 5. Let's go and make it blue. So if I go into wireframe and look at, if I look from the side, this is how my toolpath will look like. First one, second one, and the third one. Right? You can see that it's machined very neatly from the top, from the bottom, and the 2 areas here. Like I said, 2 different styles, the rollover method and without the rollover method. Okay, both the styles are out here. Similarly, I could apply the finishing. So if I just calculate the finishing, the same geometry is used here. This is tool 3. So let's go to tool 3 and change the color. Let's make it that color. Okay, so this is how my finishing looks like. Now this is a spiral finishing. Now if you would like to look at how the plunge finishing looks like, let's calculate the plunge finishing toolpath. It's basically the same. The definition is the same. You see here is machining using the plunge technique. It's following the flow of the gas. Okay, that's how it will machine that port. Right. So we have seen 3 different areas today. The first one, like many of you asked me about the barrel tools. The second one was multi-axis roughing. In barrel tools itself, we saw 2 different examples, 2 varied examples. One was a simple frame kind of a part, which was pretty deep. The second one was a more general production part, like a blisk, where the walls were done with the oval form tool. And we also saw multi-axis roughing, very nice way of cutting parts that was shown on the screen for you. You can rough floor of the part. And the third one we saw today was the port machining or the tube machining. So we have seen 3 different subjects. We will now go next. Like, for example, let's add Sim 5X. I would like to touch upon a subject to touch upon.
For a moment, there's the problem.
Sydney, I probably could not hear you nicely. Can you again? Hello?
problem on will be taken